Hey guys, how are you doing? Hello guys, I'm sorry. Next, now I'm gonna solve a problem, and I just realized that I was doing a truss before, and this is the truss that we were doing. Let me show you here. This is the truss that we were solving, and I went over all the forces in this truss, and I didn't realize that I didn't prepare the summary table for that. At the end, I need you to prepare a summary table, something like that, and you put here member and all the members, the magnitude of the force and the unit, and then tension or compression, and then you start putting every single force if it's tension or compression. So add this to that problem. It says here not applicable because remember the member EC, which was this one, was zero force member, so it's neither in tension or compression. But let's look at this problem again now from the point of view that the only thing that we are asked to calculate is the force on the bar CD. If this is the only force that we have to calculate, I don't have to go through the whole process in order to do that. I only have to be, once again, a little smart, check my problem, and know a little bit of what I have to do. If I apply it first at all, if you are asked only for one bar, I would say that 99% of the chances or the times is because you have to use the method of the section. So I start thinking, how many sections can you cut? Well, I can cut in any section. I can cut up to 3 unknown bars, and this has to be one of them. Not necessarily, but in this case it is one of them. So look, if I cut 1, 2, 3, 4, no, I can't. If I say 1, 2, 3, I can't. But if I do this section like that, I can solve the problem just with that section. Look, I'm gonna copy again the drawing here. Even not knowing this is a zero force member, I don't even care about that. This is 100 Newton, 100 Newton here, 200 Newton, and now I make this cut. Because I made this cut, let's say I converted, which is not true, but I converted this force CD in an external force just for the sake of equilibrium, and this is CA. The other bar that I cut, this, and now the other bar that I cut is this one, which is FD. And remember, we have to calculate CD. How do you calculate CD? I'm gonna start saying, oh, summation of force, no, summation of moments here. No, look, it's the only thing going, the only unknown going in X. So I say summation of forces in X equals 0, and then you have 100 plus 100 plus 200 plus CD equals 0, and then you solve for CD. CD equal negative 400 Newton, which actually means that this force, I assume it was leaving the joint in tension, and the force is actually entering in the joint in compression, so CD equal 400 Newton in compression. That is all. And if you compare with the table that I just showed you before, CD equal 400 Newton in compression. But look, all the process that we have to do before, we have to do this, we have to do this, and we have to do this, only for calculating the bar that we were asked to calculate. So be smart, guys. Think first and act later. That's the way to go. See you in the next video.